So when we start talking about engineering economy, the basic premise that we have to remember is that organizations only exist because money is a thing, right? It doesn't matter if you have the greatest idea in the world. If you can't get it to market, nobody cares. It doesn't matter if you have the highest level of quality in the world. If you outprice yourself or your competition undercuts you, nobody cares. At the end of the day, you have to be financially viable or you close. It doesn't matter if you're a church, a school, an international organization, if you're making Bugattis or you're making Taco Bell cups, it really doesn't matter. You have to be financially viable, which means anything that you would do as an engineer has to have a cost justification to it. So whether you're orchestrating the project yourself or someone's just telling you to get it done, somewhere along the line, it had to make financial sense. Same thing with your personal finance. You can like nice things. If you don't make a good salary, eventually your desire for nice things, your credit card bills, and your actual bank account will not all add up, right? There has to be a balance between what's going in and what's coming out. And that is always going to hold true. So the well-being and survival of any organization comes down to money. Frankly, you guys all pay my salary. You keep the electricity on. We are funded by the state, by the federal government as a state institution, but we're also funded by tuition dollars. If you guys weren't signing up to take classes, everybody would go home. Everything has to come down to money at some point in this type of economy. We no longer exist on a barter system where people can trade a sheep for, yarn or something. Like it has to come down to dollars and cents. Now, there is opportunity. You don't have to necessarily have everything equal out at the same time or in the same way. There's some really interesting articles written on trying to understand the capital worth of an engineer's mind. So the person that thinks up the next great thing. And this is why you'll find businesses like Google and the Alphabet whole system. You'll look at a lot of the Silicon Valley companies, but even other companies that are continuing to get a little more with it. They recognize that if their people are stressed out and working 1 billion hours a week, they don't think well. They don't develop new ideas. They don't innovate. They don't take risks. They don't create. And so there has to be space to fail. There has to be space to have bad ideas so that you can have the next great idea. Now, there's a whole line of companies that ignore that entirely and just steal the good ideas that are working from other people, right? So those companies, you've got someone who comes out with a product and then someone else comes out with a remarkably similar product for just slightly less. They didn't have to pay for any of the innovation, but someone goes on and they're shopping online and they're looking for the best deal. They choose that, and all of a sudden you've been undercut by a competitor that didn't have to do any of the research or innovation. So when we think about the ability to be creative, the ability to innovate, to do engineering design, that doesn't really attribute to flat dollars and cents like the person who's working on the Toyota line up in Princeton, where you can actually allocate how much value they're putting into the car based on the takt time that the line is running and what the cars sell for and what your overhead is and what your wage rate is for that particular assembly line guy. You can boil that down to dollars and cents and attribute specific value to a specific person in jobs that create product. But in jobs that create ideas, it's a lot harder to draw a straight line. And so there is an opportunity for there to be innovation in technology, but at the end of the day, we still have to have a positive cash flow, which means we need to be able to translate things into profitability. And engineering economy allows us to help do that. Now, typically with an engineering econ problem, we're going to look at it very much the same way we would with any other engineering problem-solving process. You have to develop alternatives and look at the differences between them. There's got to be some sort of consistent measure of unit and have all the relevant data. So for example, somebody mentioned a Bugatti. How would you compare that to a Ford Pinto? All right. And what in turn do you get for that? Significant decrease in cost. What's the difference there? So we've got form and function, right? What is the thing actually doing? How well is it doing that? How does it look when it's doing that? How does the customer feel when they're interacting with it, right? Those are all considerations that you can actually boil down to an economic analysis. You can actually translate those characteristics so that you're comparing like ideas. Now, if anybody ever buy like a knockoff product, like maybe you bought like a really cheap backpack and you find that you're having to buy a new backpack the very next semester. So sure, it costs you very little to buy, but you're having to replace it immediately compared to getting a high quality backpack that you've had since middle school. Hold that up. Let's see this. First of all, who made it? Who's it? Okay, Oakley. So that's known as a reputable quality brand, right? Lasted since middle school. First of all, you take care of your things well. Kudos. So when you think about products, some products you get with the intention that they're going to be consumed, right? You're going to go through them, use them, abuse them, throw them away. They don't need to be high quality. Other things, you get them and the expectation is that they would last a significant amount of time. Well, is the, low cost brand that you have to replace every 4 months really cheaper when you compare it to a product that can last a decade at this point? Is that really cheaper? If I have to replace something twice a year, every year for 10 years, compared to one product that I buy once, which one costs me more money? Well, we can do an economic evaluation of that. We can say you've got a lower cost, higher replacement cycle. You've got a higher cost, no replacement cycle. This is what we're going to use as our interest rate for understanding the time value of money. Bam, we can calculate that. So the idea of equivalence and having a common unit of measure to be able to compare different alternatives is something that you can do in every realm. Now, there are times where a company will look and they will choose the least expensive option for right now, even though you tell them it's more expensive in the long term. What's one reason that you can think of why someone would do that? Okay. So you're developing something. Do you mean more in the avenues of you don't know how it's going to go? So do the cheap thing and kind of proof of concept direction? Absolutely. So proof of concept, that's a great one. What's another one? Okay, right? Sometimes you think, yeah, it'd be awesome if we could buy the Cadillac version of X. We don't have the funds. And so you buy the Pinto version, right? These are real choices that companies have to make. And so when you're working for a large corporation that has a lot of liquidity, it's got cash on hand, it can do multiple initiatives simultaneously, they might want to know ultimately what's the best economic choice. You work for a small mom and pop company that has less than 20 employees, and they're with every payment that comes in from a customer, they're writing the checks out to their employees and like, ooh, maybe we don't get paid as much because we're the business owners and we have to pay everything else first. That type of company might have to make the short-term decision because that's what cash they have on hand now. So not all economic evaluations are going to necessarily be the lowest cost is the best option, but sometimes they are. And sometimes they are for different reasons. So when we do our economic analysis as engineers, part of what we need to be able to do is paint the picture of why they cost differently how you might approach it, when it's more sensible to say, yeah, we're going to do one and see if it works out. And if it looks good, then we'll upgrade and have these types of costs, proof of concept. Or, hey, we need a duct tape solution today. This is what we're going to do. We don't have the money for the long-term sustainable solution we'd like, but this will do the job today. Those types of decisions are all going to be part of your economic analysis. Because just like engineering statistics, we're not mathematicians. We're not doing math for the sake of doing math. We're doing math to make decisions. And to make decisions, you need to be able to put all that data together and make the best decision for the company. So your book gives you a little handy dandy chart to show kind of the difference between the engineering design process and the engineering economic process. Oftentimes, if you're working on a project and you're the project lead, you're kind of doing these simultaneously, right? You're taking that, you're developing the idea, you're developing the cost model as you go, you're presenting all of this information to whoever the stakeholder would be. It might be your boss, it might be further up the chain of command, but you're doing this process concurrently. And the point again is that the ultimate goal of this is to make decisions, to actually have a point of action. It's not to get a number. It's not a numerical solution as much as it is a decision solution, a turning point of what happens next. So some of these definitions you'll see in our book, and we'll use them in formulas in different ways. So when you think about fixed cost, what jumps to mind? Fixed cost. Go ahead. Okay. Yeah, so you might, depending on the business, can determine what a fixed cost is. So if you're personal finance, what might be a fixed cost for you right now? Anybody living off campus? Okay, so if you pay rent, right now that's a fixed cost. You're going to pay that every time. You don't pay that, you lose your housing, right? It's not optional. You don't get to decide, maybe this month I'd like to have a little more money for myself and not pay my landlord or mortgage, whatever the case may be. Fixed costs. It stays the same. It's recurring. It's an obligation. You cannot choose to move out of it. Now, labor can actually be both fixed and variable, because if you have salaried individuals that you have under contract that have not given you any reason to terminate them, you've made a commitment that you're going to pay that salary. That is a fixed cost. It's recurring at a specific interval. The company is, kind of on the hook for that cost, and that is budgeted as an ongoing recurring cost that they assume. Now, variable cost labor might be if you have contractors or if you have hourly workers. So for example, my husband's a nurse in the ER, and they're scheduled at 3/12s a week, but then they also do incentive shifts where they ask people to come in because they're really short on help. The way they get them to come in is they offer them a wage increase. So not only is it more hours, but it's hours at a higher rate. So had the originally scheduled individual come in, they would have been being paid X. But because that person didn't come in and they still need the help, they're paying X plus a differential. It's costing them more. It's not costing them the fixed scheduled cost that they had assumed based on the schedule. It's costing them a higher rate because they had to incentivize people who weren't scheduled to be there. So labor can be fixed and it can be variable depending on different scenarios there. Incremental costs. What do you think about incremental costs? When I say that, what comes to mind? Any ideas? So have you ever had something where you were paying it at set intervals, but for a shorter duration? So anybody seen on like Instagram, what is it? Karma, Pay Karma, something like that. I don't know. I always have ads for it, but like it offers to divide it up into weekly installments or into monthly installments instead of paying one lump sum. So it's not a fixed cost because it's not an ongoing expense. It's a short-term way of divvying up payments, but you might have that. So for example, we just ordered some new robots for the AEC. we had to pay a certain percentage of that order up front to kind of guarantee that we were going to do that, right? And then we pay the rest upon arrival. If you were taking a big vacation package, they might require a deposit of a certain amount that goes towards the vacation, and then the balance would be due at another period of time. So incremental costs are short term. It's a singular cost, but it's been divided up into sections somehow. And those can be variable based on what the example is and what is required. Sometimes that's negotiated. Contractors oftentimes will require a certain amount up front when they quote out the job. Like if you're going to have someone come and build you a deck, because they have to go buy the lumber, right? They have to go buy all the materials up front. Typically that material cost, they want you to pay up front when you agree to hire them for the job, but it's not until the job is completed that you actually pay the remainder of the balance. And basically at that point, you're paying their labor hours, right? But because they had to outlay the expense for the materials, you pay a certain percentage up front. Those are incremental costs. They happen in businesses all the time for business expense. Direct costs are costs that can be directly associated with the production of whatever it is that makes you money. Coming from a manufacturing background myself, oftentimes I think of these as direct to the manufacturing process. So for example, someone that works in marketing does not help build a Toyota Camry, but the person on the assembly line does. The commercial spot during the Super Bowl that says, go buy a Toyota, does not help build the Toyota, but the robot that's doing the welding does. Direct, indirect. Now, if we didn't have our good friends upstairs in marketing helping to convince people to buy our product instead of someone else's, we wouldn't sell as much as our product. And remember, we need to make money to be viable. We need our friends in marketing. Not as much as they think we do, but we do need them. It's a symbiotic relationship. If the engineers weren't designing and creating new products to sell, marketing would have nothing to do. If marketing wasn't helping to get people to buy stuff, we'd lose our jobs anyway. So it's a symbiotic relationship. We're all needed to get the job done, but some costs are direct and some are indirect. So maintenance, what do you think, direct or indirect? Any opinions? We can talk about anything you'd like. Okay, so we have labor considerations for maintenance, but then there's also the consumables, things that are replaced on a regular fixed interval that you might be able to predict, lubrication, belts, bearings, but then you have the, oh shoot, someone drove a fork truck into this and we need to repair it. We weren't anticipating that. Variable, indirect, incremental, potentially cost, right? So we can actually stack these vocabulary words in a singular sentence and make people hate us. But the idea is that multiple categories will work together, right? So you might have a variable cost that's incremental, that is indirect or direct, describing some event that needs to take place, and you're the engineer that's having to put those costs forward to management, right? And figure out where they go in the budget. So maintenance is one of those things. I use maintenance as an example every semester because it's actually funny. It depends on the company. Some companies write off maintenance as indirect, even though there's regularly scheduled maintenance and there's fixed labor associated with that because you have maintenance workers who are on your payroll as an ongoing. So you have a fixed cost associated with them, but you're considering them indirect because they're not directly contributing to the making of your Taco Bell cup. That could be the stance that some companies take. Other companies take it as direct because if maintenance doesn't keep the equipment going, the equipment shuts down and you're not making a damn thing. So, not good at being recorded. I gotta watch myself. So when you think about these things, these are all stackable they all interact with one another, and you kind of, again, it doesn't necessarily sound like everyday language that you would use with your friends or anything, but certainly if you were talking to the accountants or the people that are managing the budget, people that are doing the reconciliation of all the projects over the course of a quarter at a company, these are all the terms that they would be looking at as well to see where that pool of money is coming from to pay for the specific things. And when you're looking at adopting new technologies, like you want to buy a new robot for your line, there are things that are going to be, that's an incremental cost. You'll have an initial outlay, you'll have to pay more upon receipt. You might have fixed costs associated with ongoing maintenance that's required, that's recurring specific to that. But you might also have some indirect costs like programming. You might have to bring in a person from the company to do a training with your people to teach them how to interact with that particular robot. That would be a variable indirect cost associated with that purchase of a robot for your line. So these do get piled in different ways. There is going to be a quiz posted online about these terms, so hopefully you've been taking notes or you have the textbook and can go look them up again. Opportunity cost. What do we think about opportunity cost? Hagen, I'm just going to call on you. That's one potential. It's not the only way. Go ahead, Anthony. Right. Right. So opportunity actually has pros and cons, right? There's risk associated with it. So opportunity cost absolutely can be this idea of investing in something. And that's kind of what the car is too, right? I don't need a new car right now, but I have the opportunity to get a newer car at a bargain basement price, kind of like the opportunity of a stock or a bond or some investment option that could be of a wide variety with businesses. So opportunity cost is really looking kind of both from the positive and negative angle of you don't have to do it. So for example, if you're working in a company that has more than 50 people, you are regulated by OSHA. OSHA comes in and says you have to fix X or we'll shut you down. You have to fix that. It's not an opportunity, it's a mandate. But you have an engineer who says we can increase productivity by doing this improvement. It has a payback of 18 months, meaning we will have covered the expenses associated with the project in the first 18 months. And then everything after that 18 months will be additional revenue or additional productivity or a lower operating cost. You know, we can look at it from a couple different angles. The company has a choice to say, yeah, or nah, we're not going to do that right now. That opportunity cost is the differential between the benefit that could have been received and the choice to not do it. So typically there's an outlay of cash of some kind so that you take advantage of that opportunity in this moment. But you expect a return on that investment, which is why the stock option is such a good example of that, because you would expect a positive return. But sometimes, like the car, that positive is not something you really need right now. You're not really feeling like you need a new car. Your current car is working okay. You've got it in a sweet spot of like ongoing maintenance where you kind of know how to keep it going, and you don't need to lay out that additional cash. Or sure, that project sounds great, but we've got 3 other projects going on right now, and I can't spare the people to go do that, even though it's a good idea. So there's this tension between the investment now in a good idea that should give you some sort of return and the cost of not doing that. Because if we just keep doing things as status quo, nothing changes, which is why in every project, there are always two options. One of them is called the do nothing alternative, AKA you don't do a project. Now you can use this with your professors to try to negotiate. Like, Dr. Nelson, how about we do the do nothing alternative for this project? And I don't do anything and everybody else does. You can let me know how that goes. The do nothing alternative means we don't take that opportunity. We don't change anything. Costs remain as they are. And sometimes that costs you more. To do nothing will ultimately cost you more. One of the senior designs that was presented this past semester was by a student that I was working with, and he's working at a company where they had used a robotic cell to replace labor because post-COVID, they've had a really hard time keeping people in that specific position. It's hot work, it's dangerous work, it's not fun, it's a long 8-hour day. They were getting very high turnover, and sometimes their production lines had to shut down because they just didn't have the manpower to keep them going. By replacing them with the robots, it doesn't matter whether or not they have a person in that position, they can run all the time. They're adding 8 of these robots across their factory floor. Workers that had been there that are being displaced are now being moved to other production lines to even increase the productivity further. It was a good project. It was an example of choosing to move forward with a large initial capital investment to stave off the issue of shutting production down because they simply didn't have the manpower to do it. So sometimes the do nothing alternative actually equates to negative dollars. It actually costs you money. So doing nothing isn't always just zero. Sometimes it's negative. And then our last one is life cycle costs. We won't spend a huge amount of time on this because typically we work on study periods, but life cycle costs encompass everything associated with the project, meaning if there is a point in time where I'm going to dispose of something, I'm going to factor in those costs as well. And maybe there's resale value associated with it. Have you ever noticed when you rent a car, they're only ever like 2 years old? It's because they buy these new cars and then they sell them and then buy more new cars so that they never have to do any maintenance on any of these. They're always under the maintenance warranty of the manufacturer. So they don't have to incur any of the maintenance costs for any of those rentals, which is good because they have people driving it like it's a rental car and the maintenance could actually be quite expensive. All of those cars, once they hit that 2-year or 3-year point, depending on the manufacturer and what their maintenance agreement is, all of a sudden get sold. So they have an initial cost of the purchase price of the vehicle, but then they're going to recoup when they resale that vehicle with high mileage but low years. That has a value associated with it too. The life cycle costs would incorporate the initial purchase price, the ongoing cost of operating the vehicle, and that resale value at the end. It would encompass all of those things. Have you ever done like demo by yourself on your house or something, or on an apartment, like helped out with a construction project where you didn't have a contractor coming in and doing it, you were doing the work by yourself? How annoying is it to have to like dispose of everything? Because this isn't stuff that like the municipal trash wants to pick up. Like sometimes you need to take it to specialty places because it's toxic, or you want to recycle it, like the copper wire, you want to get money back for that Bear Bright, or you've got a toilet and like who wants to pick up a toilet when you've demoed a bathroom? Like we let our kid take a sledgehammer to it and just beat the crap out of it in the yard and then throw it away from there. But demoing costs money. Roll-offs cost money, right? Disposal is a cost as well. It might be a low percentage cost out of the total cost of the project, but it does have a cost associated with it. So when we think out costing projects, we go all the way through the end of the life cycle, the disposal of the item, except for things like capital projects. So who were my civils in the room? Raise your hand if you were the civil. Yeah. So bridges, tunnels, roads. For those, we call them capital projects, and we'll calculate those a different way because while you do maintenance and upkeep on it, very rarely do you tear down a bridge you've just put up, within like 50 years. The life cycle of capital infrastructure is considered long enough that you consider it to be infinite. And so we don't worry about the end of life for building the new bridge going across to Henderson. We just look at it as it will be there for eternity. It won't, but that's someone else's problem because it's far enough in the future. We don't have to worry about it. So there are times where you do capital costs equations and you just say the life cycle is infinite. For most engineering projects outside of civil engineering, you have a lifespan associated with it. And so that is what we talk about when we say life cycle costs. And so this graph, I'm not going to spend a huge amount of time, but it just kind of shows the ebb and flow that you incur different costs at different times. Oftentimes in actual physical products, there's a large cost at the beginning to get your manufacturing started, but then you start making revenue off of that and the cost per unit drops dramatically. And so your costs taper out over time. For service industry, you might have a lower cost for initial onboarding, but then the people required to do the service, that has a higher recurring cost over time. But again, you're collecting revenue to offset that. So our total life cycle cost calculations include the revenue, the initial outlay, the capital recovery at the end or disposal costs, any sort. You balance all of that out and you're able to calculate a total cost looking at your fixed costs, your variable costs, your revenues, and how those all happen at different periods of time. So those types of calculations we'll do later in the semester as we continue through. So at this point, we're going to take a break and we're do a quick poll. How are people feeling? Do you want to move on to chapter 3 or do you want